Greetings, this is Mark Anderson for Keller Community College, and I'm going to be working with you today on the first part of Chapter 2, which talks about frequency distributions and the kind of graphs that we can make from it. For this part 1 of the video, we're going to look at tally charts, which just basically deals just with frequency and percentages, and then we will move on to histograms, frequency polygons, and the ogive. So the first thing I'm going to do is I'm going to look at this tally chart, and this is merely where we are going to count up the number of times someone responded to a question about where do they get their news from. We have 4 different choices here. We have internet, newspaper, television, or radio. And so what I'm going to do is put down a letter for each of these 4 categories. I could write these all out, but I stands for internet, N stands for newspaper, T for television, R for radio. And now what I'm going to do is make tallies. Like I can go from left to right and say N, and make a tally for N. And then there's another N, make a tally for N. And I'll put 1 tally mark every time it shows up. There are 3 T's, so I will go 1, 2, 3 T's. There's a tally mark for I. There are 2 more T's. Now, when I get to my 5th tally mark for an item, I will cross like that so it's easy to count at the end of this. I have an I, and I'll put a tally mark for I, a T again, another I, an N, and an R for radio. So I can go through this very methodically and cross out the letters as I go by them, and that's going to help me fill up these tally charts. If I was to do all of this for the next 3 lines, I would have a total of this many for internet, and the frequency would be 12 because that's how many there are. There's 5, 10 plus 2 is 12. There is this many for newspaper, so that would make a total of 10. For television, this has the largest amount, which is 18, and for radio, like television, has this many, and that makes a total of 10. So that completes my frequency chart for this sample size of 10, 20, 30, 40, 50 pieces of data. I can now get my percentages. Now, in the previous video for session 1, we talked about, for just a quick moment, that observed or desired over probabilities, or the number of possibilities, gives you a percentage. So 12 people who chose the internet as their most common form of news, out of the 50 respondents, would give me my percentage. Dividing these two on the calculator would give me a decimal of 0.24, or moving the decimal 2 spaces to the right, 24%. 10 out of 50 would be on a calculator 0.2, which is not to be confused with 2%. That's actually 0.20, and that would be then 20%. An alternative way of finding percentages is if your denominator can be easily made into 100, you would then do the same thing with the numerator, and that would give you your likely percentage. So for this one, where we'd have 18 over 50, the 50 can be made into 100 by doubling it, and we would double the 18 as well, which would give us 36%. Though you can, with technology, divide the 2, gives you 0.36, or 36%. And finally, the last one, which we have actually done before since we had that up above, 10 divided by 50, which is 0.2, or 20%. And this finishes your tally charts when you organize your data here. This is a very straightforward way to just count and do a percentage-based system. And actually, I've made videos on how to turn this into pie graphs, and I can send you those links if you're curious. You can easily Google search them as well. And I use Excel when I make pie graphs, just because you can easily type in the frequency of your items and then your categories, and it will do a very quick job in making a very accurate pie graph without the need of a compass or other utensils to make sure you got your size of your wedges correctly, or done correctly. Well, this moves on to the big part of this video, which is creating a histogram, a frequency polygon, and the ogive. Now, the first thing I want to do is show you that these graphs are going to have some shapes. So before I run through those 6 parts, what I'm going to do is I'm going to show you some shapes of some distributions. First of all, normal distribution looks like this. Skewed right distribution looks like this. And then skewed left distribution looks like this. The normal distribution is, if you can imagine a class that had a normal distribution, most of the students would get a C. A little bit less of those students would get D's and B's, but very few students would get A's and F's. This is an example of a normal curve. We're going to look a lot at normal curves in the next few chapters, but you're going to find that most of the data that's in this chapter is going to be either skewed right or skewed left. Skewed right, or skewed positively, means that most of the data is low, with a few positive values that are skewing the data to the right. When we look at averages, we'll notice that averages get skewed to the right with a few high scores and mostly low scores. Conversely, if you have a data pile that's skewed left, those low scores are skewing the data to the left because they are dropping the average. If you had a classroom that had a skewed right distribution, most of your students would be failing with a few A or B students. And these few A or B students would be raising the classroom average, which would be terribly misrepresentative of actually the class as a whole. Whereas the skewed left distribution has most students with A's and B's, and fewer C's, fewer D's, and a very few F's. But with a very few number of students down here, it is skewing the data to the lower end, which means that this group may not, on paper, be as good as the data suggests, because the average could be lower than the overall clump of the class. So what we're about to do with these next two examples is we are going to look at organizing some data from raw data, and then we are going to use some tables to help us figure out how to draw these graphs. So what I'm about to do is go to the next slide, but since you have this worksheet in front of you, I strongly recommend that you may want to flip back and forth or pause the video, because I will be going over these 6 steps, talking about the graph that we're going to set up on the next 2 pages here. So what we have here is we have these 50 states, and these 50 states are broken into these counties, divisions, or parishes. So what we have to do is we're going to take a look and see, like, the smallest, one of the smallest states has the fewest number of cities and parishes in them. So what we're going to do is we're going to look at what the book wants us to divide this into. Your book is going to ask you to break this into classes, because we have a very wide range, or a very large distance between minimum and maximum in this data. In fact, the smallest number is a 3, so one of the smallest states has 3 counties, divisions, or parishes in it, and the largest state, with the largest number of counties, divisions, and parishes, is a state that has 254. So the range between these two is 251. Now, something you should look in every story problem in this section is it's going to tell you in the book how many classes there will be. And what this is going to do is this is going to set up how many different bars or peaks or polygons or points that we're going to need on our graph. It says here in the worksheet it will always be given, but I have been proven wrong before. Sometimes I do assign a homework problem where they don't tell you how many classes. So you can honestly just be a little reasonable about what you want to use. You may choose 5, 6, or 7, whatever's reasonable. But we're going to choose 6, and to figure out the gap in our 6 classes, we're going to take our range, which is 251. So we've taken our max minus our minimum to get our range, and we're going to divide that by the number of classes. And as it says in the instructions on the previous page, we're going to round up. So 251 divided by 6 gives me 41.83 repeating, so that's going to give me 42. Now, if you divide these two numbers, let's imagine that this number 251 was divisible by the denominator. If that was the case, you would get a whole number here. If you find that you're not going to actually encapsulate your last data point, you may have to add 1 to this number here. So if you ever divide two numbers and get a whole number here, you may need to add 1 to that just to get you to encapsulate the data within your limits. Because what a limit is a limit starts with the minimum number here, 3. And it goes up by 42. So here's 45, 87, 129, 171, and 213. So here are your 6 limits, 1, 2, 3, 4, 5, 6. Now these is the line represents this first bar of your histogram is going to represent any piece of data between 3 and 44. And then this line is going to represent any piece of data between 45 and 86. You'll note that I'm getting that because I don't want overlap between these two numbers. So if you have a state that's between 3 and 44, you're going to put them in this first group. And if you have a state between 45 and 36, or 45 and 86, you're going to put them in the second group. And this is going to go 87 to 129, 129 to 170, 171 to 212, and 213. Now, since you haven't had a number down here to kind of base that off of, you'll note that these are also increasing by 42 each time. So this goes to 254. Okay, so that gives me your limits. Now, I'm going to show you when I get to my histograms, polygons, and ogives, I'm going to show you how the book may choose either the limit or the boundaries in representing how wide those bars are. And I'll let you do any way you would like. If you want to match the book, that's great. If you want to match what I do, that's good too. But now I'm going to talk about the boundaries. The boundaries was a concept that we learned back in Chapter 1. Back in Chapter 1, we learned that a boundary was the lowest a number could be to be rounded up to this number, and that would be 2.5. And the number on the upper end that it would basically have to round down to it, which is 44.9 repeating, but we're going to put 44.5 just because we're going to have overlap with boundaries. Limits have no overlaps, boundaries do have overlaps. So if we go down from 45 to 44.5, there we go, and this up to 86.5. 87 down to 86.5, 129 up to 129.5. 129 down, 170 up. So these are all being dropped by 0.5, and they're all being, that should be 128.5, not 129.5. Sorry about that. So, or is it going to be that? Yeah, this should be 128.5 over here too. Sorry about that. All right, so this is 170.5, this is 212.5, and dropping that by a step, 212.5 and 254.5. So this means that if your data point is between 2.5 and 44.5, you're going to be in the first bar graph. And if the boundary is going to be 44.5 to 86.5, you're going to be in the second. Now, what's great about this is that you'll see that since we have no decimals in the original data set, we're not going to have any overlap. We're not going to have any problems determining if one dot is within one bar or another. But it does definitively kind of say that this maximum point of 254 is in the last or sixth bar. Now what you'll do for frequency is you're going to go through and say, like we did on the previous page, 67 is a frequency tick mark right here. 27 appears here. 15 appears here, because I'm taking the number and I'm checking to see which place does it, reside in. 75 appears here because it's between 45 and 86. 58 belongs here. 64 belongs here. 8 belongs here. 67 belongs here. Whoops, I did 5 tick marks straight up, and I probably should have just crossed that. I'll make that fix when I get to that. Another one. 159 takes me to this fourth row right here. 5 takes me to the first row. 72 takes me to this second row, and now I have my 6 total from that row. 23 brings me to the first row, and then 3 also brings me to the first row. So I have 6 so far from this column going left to right, and I have 6 here and one here. Now, going through the rest of these, since you probably don't want to watch me do all of these by hand, I'm going to finish the frequency chart by realizing that this is going to end at 5, 10, 15, 19. So the first bar of my histogram and frequency polygon is going to have a height of 19. My second bar is going to have a height of 17. My third bar, if I went through and did all this data out, would have a height of 12. My fourth bar would have a height of 1. My fifth bar would have 0 states, and my sixth bar would have 1. And if I added all of these up, 19 plus 17 plus 12 plus 1 plus 0, I get a total of 50. These are all 50 states. And you can see that this data is mostly clumped around the smaller number of counties, divisions, and parishes that they are divided into, though there are some very big states with a lot of divisions, and that will skew the data to the right, even though most of the data is on the small side. Now, what we have just done up to that line that I just drew vertically is done all the work that we're going to need for the histogram and the polygon. Now, what I want you to do is make sure that this is copied, because I'm going to have to scroll down to make my graphs for the following pictures here, and I would like you to refer back to the work here on these 3 columns. You'll note that the cumulative frequency is not actually drawn yet. The cumulative fixed frequency is for the ogive. And the ogive graph is going to be what we do at the bottom of this page, but I need to come back to it because I feel like once we have this frequency and our limits and boundaries, we can actually do the histogram and the frequency polygon. So let's scroll down a little bit and show you first the frequency histogram. The frequency histogram is going to start off with, on the x-axis, the number of your counties, parishes, and divisions. Now, the x-axis or the x-scale is going to start, and this is if your book uses limits, it's going to start with the minimum limit, which is 3, and then move up by that 42 that we found each time. So 42, 42, 42, 42, sorry, 171, 213, and if I do 42 to this number here, I would get 255. So that's adding 42 to each of these numbers. Sorry that 171 looks a little messy there. Looks worse every time I try to fix it. But what we have on the left-hand side is frequency. Now, before I fill out the frequency, I must also tell you that the book may differ in the way that it uses this x-axis. Some books use these limits, like 3 through 45, and they write it inside or in between these two tick marks. And I misspoke there. They would put 3 through 44 within this gap, and then they would go 45 through 86 in this gap, then 87 to 128. So the book would use limits inside of these spaces. Another way the book can use this information is it can use it as boundaries. It can go 2.5, sorry. It can go 2.5, it can go 44.5. Now you'll note that there is overlap here, but the book could decide if it wanted to, instead of using limits, it could use boundaries, and that's just a matter of preference. I personally am a fan of limits, but if you decide to use the boundaries, I literally will not mark that down on the test. 54.5. All right, they may have lines drawn between the two of them, and those lines may indicate that this is the span between the two of them. They may have them between here. So I'm just basically saying that there's a lot of different ways to do it, and since I've drawn that up and marked that up a little bit, I'm going to go back and start this out my preferred way, which is writing the limits, but only writing the limits on those tick marks, not between the tick marks. Though, as I said, you will be seeing the solution manual or some textbooks doing it that way. But what we do here, since this is our number of CPD, or your counties, parishes, and divisions, we're going to look on the y-axis here, and the y-axis is in terms of frequency. Okay, so the y-axis in terms of frequency. So back on the chart that we finished earlier, we noticed that we had a 19, and this is actually our tallest bar. I happen to have given you 10 tick marks, so my suggestion would be to go by 2s. 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That should look like an 8. Again, the more I fix it, the worse it looks. But that first group would have 19 data points in it. And we'll put a 19 at the top here. Then the second group, with between 45 and 86, would have 17 in it. So that is going to mark the height. And I put the number on the top of this here because that makes it really easy to grade for me. And you're going to want me to have an easy time grading your paper, I'm sure. And then we're going to go to the third group, which has a total of 12. The fourth group, which has a total of only 1, so that is halfway between that first tick mark. The fifth group has 0, and I could put a 0 there if I wanted to. I could just leave it blank as well. And the sixth group has 1 as well, which definitely gives me this skewed right shape, because most of my data is low, and these two states are definitely going to be pulling the averages higher. So this is making a relative frequency histogram. So apart from the variation that you'll have in this x-axis, everything else should look the same. I am now going to talk to you about the relative frequency polygon. Now the relative frequency polygon is going to have some similar characteristics. The y-axis is going to be frequency again, with a height of 20 going by 2s. To make this a little faster, I'm going to mark only the 10 and the 20, but note that every single tick mark is going by 2s. But on the x-axis, we're not just talking about the number of CPD. The number down here is going to represent medians. And the median is a number between two other numbers. So if you want to think, gosh, what's the number between 3 and 45? Well, you can go 3 plus 45, and 3 plus 45 is 24. So instead of having 3, 45, 87, 129, like in the previous graph, these are going to have the medians of those limits. And to find the median, you would take the beginning of that limit, which is 3, go to the next part of the limit, which is 45, add them up, divide by 2, and that gives you your median, because the number between 3 and 45 is 24. Then we're going to look at the difference between, we're going to go 845 plus 87, divided by 2, and we get an answer of 66. And then we'll go to the next part, which is 87 plus 129 divided by 2 is 108. You'll also notice that me going from left to right is also going to be a difference of 42. So adding 42 to each of these numbers, if you're sure you got the first one right, will continue the pattern: 150, 192, and 234. The reason why these dots represent the medians of the data is because the height of these graphs represents that middle of the data. Just like our first bar had a height of 19, this first dot is going to have a height of 19 because the polygon is going to make a many-sided polygonal shape of the data. It's going to look like a mountain range, or maybe a video game landscape from an ancient video game, let's say like Atari's Lunar Lander. But what we're going to do now is continue with this first group. The second group had a 17, so that was right here. The third group, which has a median of 108, which is the group that represents all states between 87 to 128 counties, districts, and divisions and parishes, had 12. Then we had 1 for the next group, 0 for the group after that. Notice I am putting a data point down there, and 1 after that. Then what you need to do is draw straight lines, not curved lines, straight lines between the dots, because that gives it its polygonal shape. And there you have the mountain range. You would connect this to the ground like so. It would be straighter than that. And you would also connect this to the ground like so. So it completes your mountain range, not that double line I just drew. Now, you'll note that this is moving forward by 42, so this distance between here and here isn't quite the same distance as the rest of these tick marks, so there is a little bit of play right there. But that is a relative frequency polygon. So the same heights as before, but a much different shape based on the medians. You'll also notice that some books, instead of using the limits, use the boundaries. And so if you went 2.5 plus 44.5 then divided by 2, you'd get a median of 23.5. And again, this is if you use boundaries instead of limits. If you go 44.5 plus 86.5 divided by 2, you get 65.5. You would basically get a half step, or 149.5. You would have a half step lower than each of these. And I don't care which ones you use. Again, I'm a big fan of limits because that's going to be probably less messy than what you're, used to. So for the final graph that I'm going to teach you in this section before giving you another problem to look at here, is we're going to talk about cumulative frequency. Now, in moving the worksheet here, everything went away, but I want to bring back that the first group had 19, the second group had 17, third group had 12, 1, 0, and 1. And to remind us about the limits, this is 3, 45, 87, 129, 171, and 213. And I want to use these limits to kind of help us out here. 44, 86, 128, 170, 212, and 254. What we mean by cumulative frequency is we're going to add up these numbers as they go down the chart. You'll start with the first number of 19. 19 plus nothing above it is 19. So there are 19 states that were less than or equal to 44 counties, divisions, and parishes inside of their jurisdiction. Now, the next group, we're going to take the 17 and add it to the 19, which makes a total of 36. So there are a total of 36 states that are less than or equal to, I'm going to look over here now, that have less than or equal to 86 counties, divisions, and parishes inside of them. Now I keep adding up. I go 19 plus 17 plus 12. That gives me a total of 48. I'm almost at all of my states here. Almost all of my states have less than or equal to 128 counties and divisions and parishes. And I can use these ditto marks, throughout if I wanted to. Now I have only one more state, so that would give me 49 have less than or equal to 170. Got ahead of myself there. 170 counties, divisions, and notice that this is a 0, so that actually keeps it the same. 49 also have less than 212 counties and divisions and parishes. So this fourth row right here wouldn't be that useful to us. The fifth row says the same thing. And then finally, all 50 states have less than or equal to 252 counties, divisions, or parishes. Now, some books may not use limits, some books may use boundaries, and each of these would be 0.5 higher because they would be going off of those numbers at the end of these boundaries, the 44.5, 86.5, so each of these would have a 0.5 on the end of it, depending on if your book used that. But what I would like you to do is make sure you have these numbers, 19, 36, 48, 49, 49, and 50. I want to have that written down because as I move my worksheet down, you're not going to be able to see what's there. So I'm now making sure I'm on the right page. Okay, I'm on the right page. So now I'm on the relative frequency ogive. Okay, so what this means now is that the left-hand side is going to be frequency again. And then down here, we're going to have the numbers that we used up above for the limits or the boundaries, whichever you used for the histogram. Whichever you used for the histogram, this will be exactly the same thing. All right. And this is the number of counties, divisions, and parishes in each state. and this is the total frequency. But in this case, we have to go all the way to 50 states. So this is a graph best broken up by fives. This is 10, 20, 30, and 40. So what you're going to do is start off with the first height, which happened to be 19. And 19 we're going to put right here at the 45, and we're going to do that because we have 19 states that are less than or equal to the 44 that we had, but we'll put the dot right there at the 45 because that's going to continue a new jump, because this is going to jump all the way to 36, and it's going to do that right about here. And that right there, that 36, this represents the 36 states that have less than or equal to 86, or 86.5 if you used boundaries. Then we go all the way to 48, and you'll see that there's not a lot of movement here at the end of this graph. Let's see here, there's 48, and then we're going to have two 49s because we added one state, and then there was none other state to add, so it plateaus right here. And then it goes up 1 to say that all 50 states have less than or equal to 255, less than or equal to 254 counties, parishes, and districts. And the reason for the Ogive, sometimes we look at that when we want to look and see how fast the population is. You can either have a graph that looks like this, which is going to be skewed to the right. You can have a graph that kind of moves up like a exponential growth, which is skewed to the left because most of the data is on the right. But if you have a very straight line like so, then it's going to be a very flat data. It's gonna be very, very, very flat, very constant data, where all the bars are about the same height, as it linearly grows. Okay, so what we're going to do is we're going to have you maybe pause the video a little bit because it's time to actually let you practice this a little bit. I would like you to look at this page, and I'd like you to try on your own. I'd like you to try on your own to come up with your maximum, come up with your minimum, come up with a range, and come up with the number of classes, which is 6. And then figure out how much gap you need in each of those 6 groups. So pause the video here, write down your maximum, write down your minimum, and then your range, and then use that number for this to figure out how wide each gap is going to be. Hopefully you've done that by now. I'm here to tell you that the maximum in terms of protein grams in this fast food, we took a look at some fast food and found that one had 57 grams of protein, where one of them only had 12. The range between the two of them is 45. And to find your width for each class, you're going to go 45 divided by 6, which is 7.5, or we always round up, 7.5. We're always going to round up, and we're going to round up to 8. This also brings up the point, what if it was 7.1 or 7.2? We'll always round up, and we would round that up to 8. And also, if this happened to be a whole number, if this is 42 divided by 6 and happened to be 7, it may be safe just to round that up one more integer or up the whole number to 8, because we may not, depending on the data, we may not actually get to that final number. But since we easily rounded up, we're now going to have you start off with your minimum score of 12 and create all of your limits, all of your boundaries, all of your frequencies, and your cumulative frequencies. Please pause the video and do this. I am going to show you the correct answer once you unpause it. Okay, let's go take a look here. So what I'm going to do is start off with 12, and since the gap space is 8, I'm going to go vertically 12, 20, 28, 36, 44, and finally 52. Now, the limit is basically where it's going to go to the next part, but not touch the previous number here, or this next number here. So 19, 27, 35, 43, 51, and since there's no number down here, all of these get added by 8, so 59. That follows the pattern. In terms of boundaries, we would go up a decimal and down a decimal from these two numbers, so this would be 11.5 all the way to 19.5, 19.5 all the way to 27.5, 27.5 all the way to 35.5, 35.5 all the way to 43.5, 43.5 all the way to 51.5, and then 51.5 all the way to 59.5. If you carefully counted each of these and put them in their respective categories, you would have 7 pieces of fast food data between 12 and 19. You'd have 17 in the next category between 20 and 27 grams of protein, 10 between 28 and 35, 4 between 36 and 43, 1 between 44 and 51, and 1 between 52 and 59. The cumulative frequency would be 7, 24, 34, 38, 39, and 40. This means we have 7 pieces of data that are less than or equal to 19 grams of protein inside the fast food. 24 of those 40 items had less than or equal to 27. 34 out of 40 had less than or equal to, excuse me, I'm squinting here a little bit, 35. 38 had less than or equal to 43. 39 had 39 had less than or equal to 51, and finally 40 had less than or equal to 59. Again, if you chose to use limits, you could use boundaries and add the decimals to those. So here's what the pictures look like. The pictures, and again, if now you have checked your, if you had to make adjustments on those tables, that would affect how you drew these pictures. So what I'd like you to do is make any last and final fixes to your pictures, to your pictures and table. Unpause the video to check to see what the answer is. Okay, so for our final answer for the frequency histogram, we're going to start off with our limits. Now again, you could have used boundaries if you wanted to, so these would be decimals instead of whole numbers. But these limits right here indicate how many pieces of data, so this is going to be our, on the x-axis here, this is protein grams inside of the fast food sources, and this is the frequency of how many in each of these different domains exist. And in this case, our highest bar is 17, so we should probably go by 2s. So I'm going to mark the 2, the 0, the 10, and the 20. So our first group is 7, so 2, 4, 6, 7 right there. Put a little 7 at the top. Then we're going to go 10, 12, 14, 16, 18, just a little lower than that. So this is going to be our 17 right here. And then 2, 4, 6, 8, 10, like so. 2, 4, and then 1, and then 1. And there's our histogram. Let's look at the frequency polygon. So now instead of using the actual limits, I'm going to find the median of each limit. So I'm going to go 12 plus 20 divided by 2, which is 16. 20 plus 28 divided by 2, which is 24. And I'll go 28 plus 36 divided by 2, which is 32. But I'm noticing that these are all getting added by 8. So here's 40, here's 48, and here's 56. Once you get a pattern going from left to right, you can kind of then see what that is and fill that in. This is still our frequency, and it looks like the tallest bar is 17, so I'm going to use my scale going by 2s. And then again, this is still our protein of grams inside of our fast food objects, or food, fast food objects. So this is going to be a height of 7, so 2, 4, 6, 7. That's our first data point. This is going to be 17, 10, 12, 14, 16, 17, like so. Looks like a question mark, doesn't it? We're going to connect these dots. Then 32 is going to be a total of 10. So we're going to put that at 10. And then the next one is going to be a total of 4. So it drops quite a bit right there. Make the data point a little larger. So there's 4. And then it drops all the way down to 1 and 1. So 1 and 1. Put 1s above it. Make the polygon like so. And again, since this is kind of a mountain range, we're going to kind of connect the mountains here and here. Okay, so for our frequency ogive, we are going to finally finish this video, but also go through this right here with the same limits that we have been using throughout this page of our worksheet. Now again, you could use boundaries and there will be decimals. But in this case, we have to go all the way to 40. And in going all the way to 40, that means we should probably mark these out by 4. So 4, 8, 12, 16, 20. Now, if you didn't want to mark all these, I would totally understand. 24, 28, 32, 36. So this is our frequency, or in this case, our cumulative frequency. And this is, again, our protein in grams. So our first dot point is 7, which means we're going to have 7 fast food items that have less than this 20 grams of protein. Then we're going to jump all the way to 24. All right, and that takes a stiff jump. The next one is going to be at 34, so it's going to be halfway between 32 and 36. And the next one's going to be 38, so halfway between 36 and 40. And then this one is going to be at 39, and this is going to be at 40. So slight increases here and here until we get all 40 fast food items have less than 60 grams of protein in it. All right, so if you're looking for higher than 60, you'd be out of luck for that, for at least the data we collected here. One last thing about the relative frequency ogive is that you do not connect this to the floor. You don't drop it down to the 0. It's the frequency ogive taking 100% of the data. We don't need to cut it off like a piece of wedding cake. Well, thank you very much for sticking with me through this video. This is a good one covering these pieces. In our next video, we're going to cover the remaining types of graphs for this section, which are going to be the horizontal bar graph, the Pareto charts, the plots over time, and also the stem and leaf plots. And the video will be a lot shorter. Thank you very much for watching. I appreciate your time and effort.